All right, let's move on the next topic of multiple angles. In the last video, we kind of saw how to apply allied angles, which was more of a type 2 problem, and there is another type 3 on tangents. We'll come back to that. But let's talk about multiple angles, another version of how to use trigonometry to simplify problems, and this is one of the type 4 problems. So total there are 7 types, and we're talking about the 4th type of problems that you might get in exam. Normally you just get 1 or 2 problems either for 2 marks or 4 marks, but it's important and it's not that difficult, so let's kind of knock it off. So what is multiple angles? So if you understand kind of why we need to use multiple angles, then you'll be able to appreciate what is multiple angle and why do we need to do that. So typically in the past videos, you saw that we were using, when we started out trigonometry, the first chapter or the first session, we were using compound angles, and then we moved on to allied angles, and now we're talking about multiple angles. So the fundamental difference is whenever you are given an equation or an angle which is significantly larger in size, if you see here my first point, like you are going to find difficulties in facing you're going to find difficulties in calculating the values of the angle if the angle is too big. For example, typically greater than 90, like for example 120, 135, 3000, 660, pretty much the same kind of needs were there in the allied angle, where the magnitude of the angle or the value of the angle is too large for you to calculate. That will be one of the scenarios. And then anyway, you're not allowed to use calculator. Then how do you do that? So the concept of compound angles, allied angles, reference angles that we all saw, those are different ways to simplify the given bigger angle into smaller angles based on how they are applied and what kind of formula can be used, and then we simplify that. On a similar scale, multiple angle is another way of doing those, simplifying those problems into breaking it down into simpler terms and then solving it. And there is a slight variation of submultiple angle also that we are talking about. So that's why we need multiple angles. So the reason is the same, like how do you solve for bigger angles, whether you use compound or reference or any of that, and that's the reason this multiple angle comes into play. So, and you will see when I'm going to put another video where it may not be relevant from an exam standpoint of view, but I think if you are interested to know where the formulas came from, and there might be a very rare occasion that they might ask you something to talk about, but I'm going to put an optional video for you guys, and from an exam standpoint of view, you can feel free to skip that. But if you check out that video, you will realize that this multiple angle and submultiple angles that we're going to discuss now in this session are just a special case of sum and difference formula or compound angles. They are not very kind of different. For example, if you take sine 2a, it can be expressed at sine a plus a over here, right? So this is nothing but a compound angle. That's it. So it's not very different than that. Okay, now let's define multiple angle over here. So if you see here, what is multiple angle? So if there is we have an given angle, let's say a, and if we multiply it by integers 2, 3, 4, 5, whatever you want to do, then those are called multiple angles of A. It's very simple and literal definition. And if instead of multiplying it by a whole number, if you're going to divide it by a fraction, then it becomes half angle or submultiple of angle. So from an exam standpoint of view, you're not going to get more than 2a and 3a, and a by 2, half of a. Those are the only 3 things they might ask you, and that too, they are not going to ask you to prove the theorem. They might just ask you to apply the formula, write the formula, and just prove a particular set of given equation where you need to prove left hand side is equal to right hand side. So you don't have to sweat too much about that. And I've written it here from, for example, examples from the syllabus, right? So there are only 3 variations on the multiple angle: 2a, 3a, and submultiple angle a by 2. So if the given angle is in the shape of 2a, then we will call it as double angle because it's twice, and then we will use the double angle formula that we'll be discussing. If it's fit in the pattern of 3a, then we call it as triple angle, and then we'll be using the triple angle formula to solve the problem. And likewise, if it fits in the pattern of a by 2 or half of a, then it's called as half angle or submultiple angle, and then you will use the half angle formula. And just to give a perspective, if you see here, like the way I put, if the given angle is 45, right? If a is equal to 45, and then the double angle or 2a is equal to 2 into 45 is equal to 90. So 90 is a multiple angle of 45, and in this case it's a double angle because 45 multiplied by 2 is 90. And similarly, if you see here, if the given angle is 30, right, and if you want to calculate the triple angle, 30 multiplied by 3 is 90. Again, you can calculate. So the value of the same angle, 90 degrees, you can use either double angle or triple angle based on how you divide or how you break it down, because you know the value of 30 also, and you know the value of 45 also very easily, because those are reference angles, and then you can use either double or triple angle formula to solve that. That's kind of the whole magic of this. Similarly, if you're going to use the half angle formula, then let's say the angle is 180. So the half angle is 180 divided by 2, it becomes 90. So 90 is a half angle of 180. So the definition is pretty literal, and it's nothing that you need to remember. So just a concept. So multiple angle and submultiple angle, and they are used to calculate larger values of trigonometric functions. And let's see what's going on. And like, just again, gentle reminder from a syllabus standpoint, just 2a, 3a, and a by 2. You don't have to worry about anything else. So like I said, I'm not going to talk about where these formulas came from, what are the proofs, because those are typically not asked in the exams, at least till now. In the older syllabus, they had asked sometimes. And even if they ask, it's not very hard to write them out. So I'm going to put an optional video, like I said, and you can just check that out if you have time. And if you don't have time before the exam, or if you are too short, just crunching in the last minute, you can feel free to skip. The probability of that will come is very unlikely. But in that case, then you will have to memorize these formulas, because you cannot go wrong on that one. Whereas if you understand how these formulas came in, then it will be easier for you to at least build it on the fly in case you are lost in the exam what is the exact formula. So feel free to choose whatever works for you. So in terms of formulas, there are not many formulas. So there are double angle formulas like we discussed, and within that there are 3 formulas: sine of 2 theta, like 2a cos 2 theta, 2a tan 2 theta, or a, whatever that is. And then we have the expansion of that. So for now, assume that you know where these formulas came from, or you memorize that. Let's take that assumption and proceed on how to apply that. So sine 2 theta is equal to 2 sine theta cos 2 theta is equal to cos square minus sine square, and tan theta is this. And similarly, in triple angle formulas, you have sine 3 theta, cos 3 theta, and tan 3 theta, and we have put the formulas. 99.999%, there will be hardly 1 or 2 problems that might come every other year on this, and that too they'll not be asking to solve. They'll just give you straight away the equation. You have to just apply that. That's it. So the triple angle formula, just don't worry about that. In the double angle formula also, tan is very rare. Most of the times it will be sine and cos, and I'll tell you what is important within cos also. So these are the formulas for double angle and triple angle. And within the double angle, the cos 2 theta, right, because of the equation pattern, it has got few variations on how we can rearrange the equation. For example, like I said, I'm going to put everything in the optional video, but just give you a kind of a quick data point. For example, cos 2 theta is equal to cos square theta minus sine square theta, but we know that we can substitute cos square or sine square based on the Pythagoras theorem, which is sine square theta plus cos square theta is equal to 1. So we can use that equation and substitute either for cos square theta or sine square theta, and so that we can get a different variation of the equation. And that variation I have put here in these 2 boxes. And so assume that I put the variation. So in that case, cos 2 theta might have another way of the same formula can be rewritten as cos 2a is equal to 2 cos square minus 1. And if I rearrange this itself, moving this 2 cos square a on the left side and this piece on the right side, I can get this equation. And similarly, so this whole thing is expressing cos in terms of cos. So on the left side we have cos, on the right side we have cos. Similarly, this one is expressing cos in terms of sine. On the left side we have cos, on the right side we have sine. And if you remember, like I said, it's a double angle formula. So what does it mean? That is a typical pattern, which is also very important, and it will be a good hint for you on how to apply and how to substitute. On the left hand side, the angle will be twice of the given value. On the right hand side, the angle is exactly half. For example, if you see here, it's 2 theta here, it's theta. So because theta is half of 2 theta, because the 2 goes away. Similarly, over cos theta here, the angle reduces by half. That's the reason it's called as double angle formula. And similarly for tan. Over here, if you see, it's 2a, and on the right side it's a. Over here also it's a. Over here it's 2a. So one side will be always half the other side, or one side will be always the double the other side, and that is true for all of that. So that's kind of the magic of double angle formula. For example, I've just given an example here. If you have to find cos 20, so cos 20 is cos. This is a square. I'll just fix the video later. It's like cos square 60 minus sin square 60. I'm just applying this formula over here. So cos 2 theta. So cos 120 is 2 into 60. So cos square 60 minus sin square 60. So that's, always remember that, like, the right hand side will be half of the left hand side. So these two variations, this one, let me write it down, hold on. Okay, here, this one and this one are super important. Most of the problems in the exam, whatever that you get, that will be asking you to apply one of these formulas. So either you'll be applying this, or you'll be applying this, or you'll be applying this, or you'll be applying this. One of this you'll be applying between these two. So you might apply this and this, but within these two, either you'll be applying this or this, and you'll be applying this or this. So this is very important. So just remember this. It's not very hard to remember. You know, it's just moving things around and remembering that. And as long as you get that, and I'll tell you when I solve the problems, you'll see the pattern how to solve that. Another variations of expressing sine 2a and cos 2a over here, whatever we saw, in terms of tan, again very rare, but you can just remember this for the heck of it. I don't think you're going to get. Most of the action is going to be here, okay? This is where the action is going to be. Okay, so with that, so basically if you have to memorize these three formulas over here, 1, 2, 3, this 3 here, this variations, and this one. So as long as you mug up that, you pretty much got all of the multiple angles, and then we can straight dive into problems. So let's jump on a couple of problems to see how to apply and when to apply that, and you'll get the hint in the question itself. For example, express cos 4a in terms of sine 2a and cos 2a. So now you know that the question is asking about cos 4a and 2a and all those things. Is exactly matches the pattern of multiple angles. Okay, and like I said, always remember, on one side they're asking 4a, and half of 4a is 2a. So on one side the angle is double, other side is half. So that's another clue of the double angle. And again, they're already asking you express cos 4a in terms of sine 2a and cos 2a, which means in the final equation, this cos 4a will go away, and the final equation will contain sine 2a and cos 2a. And if you see here, which one will you apply? So this is the clue here. For example, this is the only equation where you have cos 2a, and on the right hand side we have both cos and sine function, and which is half of this. So that's why they applied this formula. They have taken the cos 2a, split it into cos 2a, 2 into 2a, and applied that formula so that the final equation has both of these components. Similarly, if they ask you, I don't think this kind of questions will come in exam the way exactly it is, but this will help you solve the other problem that come in the exam. This is just for the reference, because I'm just trying to explain the context. So I've just borrowed something from the internet. I put the link here. This is not my problems. I put the link here where I borrowed it to just explain you. So in this case, they're asking express cos 4b in terms of sine 2b. That means we know that I have to express cos in terms of sine. So we can go here, and again the logic is, like I said, it's 4 on the left side and 2 on the right side, so it just kind of halves. So which is the equation over here where I have cos on one side and cos is expressed in terms of sine. So if you see here, this is the part. So there is cos on one side and it's expressed in terms of sine, and that's the formula I'll apply. So the hint will be in the question to help you understand which of these formulas you will apply. Okay. And similarly, express cos in terms of cos. So over here, which formula is there where both on the left hand side and the right hand side we need to have a cos function. In that case, this is the formula that we are going to apply. Okay, and last but not least, if you see here it's asking express cos 4a in terms of a. So it's not exactly the half, but it has gone further. But in those cases, what you will do is from 4a, you will come to half of it, which is 2a, and then again apply the same formula to come from 2a to a. Like I've written the hint here. So left hand side is 4a and the right hand side is a. So bring the 4a to 2a format, and then using the double angle formula, and again reapply the double angle on this 2a to bring the right hand side to a and apply the formula. And that's why, if you see, he has done that. He has taken 4a, apply the double angle formula, and they are asking you to express in terms of cos only. So they applied the right formula, and again this 2a he has split into further down, and finally he has got this equation. So this is kind of the game that you need to play on that one. Okay, I'm going to skip these two problems. I don't think it's required. Just for reference, you can just go through this. And before I close this session and go on to my part 2 video where I explain you some of the exam problems, there are only 2 problems, so it's like easy. It's going to be short session. You might be wondering, I just put this table, and it is just, again, if you don't want, you can skip this, nothing to do with exam, but just kind of a clarity on when we are piling up different types of problems, type 1, type 2, type 3, type 4. When you look at each type, it's very easy, but when you put that everything together, it's very difficult, or sometimes it could be tricky. Okay, what was the one that I did other, and how that difference, what is the difference between this one and the previous one? So I just kind of compiled what are the things we learned so far. And I don't think after this there are any more types which kind of match this. This will be other types in the future will be significantly different than this type. So if you see what are the things that we learned so far, we started with the reference angles or standard angles, pretty much, which is anything between 0 to 90. And primarily the reference angles are 30, 45, 60, because it's easier to do maths with that. The values can be easily memorized, and that's the reason a lot of angles revolve around that only. So those are standard angles, and if any value comes, we directly apply that. We don't do any simplification. If they ask you what is the value of sine 30, sine 45, cos 90, we just apply that. So we learned that standard angle and reference angle. And if you remember, reference angle is nothing but the angle which is the smallest angle dropping on the x-axis. That's the reference angle, because it helps you calculate the other angles also, and we discussed that in a video. Compound angle is you take any two angles, either you add or you subtract, and whatever is the net value, that's your compound angle, which is also called as sum and difference formula. And typically why this is used is the angle is slightly larger, that is, it's definitely bigger than 90, like what I said here. And that 90 degrees or any angle that is bigger than 90 can be easily broken down into two smaller angles, which could be possibly reference angles, and then for which we can calculate the values. So that's how typically compound angle come into play. So whenever you find an angle, like say for example 75, you should think that, okay, can I break this 75 into two reference angles for which I can solve and apply the formula? The answer is yes. So 75 can be broken down to 30 and 45, and you can apply compound angle. So that's how you need to think that which one I need to apply. 99.9% the question itself will say what you need to apply, but in case it's not given, I'm just trying to explain the pattern that there are zillion ways, and you can apply any of this methodology or formula to come to the same answer. So if they asked you a specific format, you apply that. If they did not ask, you should know which formula to apply. In terms of allied angle, right? So for example, if you take the example of 75, in case of the allied angle, you know that allied angle is nothing but a multiple of 90 or 180. We have discussed that at length. So how do I express 75 in a multiple of 90? So 75 is 1 multiplied by 90 minus 15, or 90 minus 15 is 75. But if you apply this concept, then the 90 will go away eventually, and what will remain is 15. But it's not very easy to calculate the value of 15. You don't know that. It's not like 30 or 45. So in this case, for 75, it's easier to apply the compound angle than applying the allied angle. Moving on to multiple angle, this 75 can be represented as 5 into 15, right? So 15 is the angle, and you multiply it by 5, it gives you 75. So 75 is the multiple angle of 15. So we can express that. But again, calculating that, because let's say it's sine 75 and you're going to apply this formula over here, then what will happen is it will come as 2 into sine of 15 and cos of 15, again, which is very difficult to calculate. So although you can express this angle into multiple angle format, just like allied angle, you can just express, but it's going to be difficult to calculate. So in such cases, you know that compound angle works well because you can easily break it down and apply the formula, and you know the value of 30 and 45, and you can easily apply that. So that's kind of a hint on when you should apply what. Similarly, if the angle is bigger, normally when the angle is bigger, then the reference angles cannot come in play because it's very hard to calculate for you. I mean, the reference angle might help you because if you say it's 180, 120 is the angle, the reference angle is going to be 60 degrees and you can calculate that. But as you go on increasing this angle, it will be difficult for you to calculate with the reference angle. And definitely the standard angle does not fit in, which is pretty much 0 to 90. That will not help you calculate the value here. So in case of bigger angles, applying this option 1, which is standard angle reference angle, is going to be difficult. And when you want to apply compound angle, sometimes it can be easy, but if the angle is too big, it will not be very easy. For example, 120 is still manageable because you can still break it down into two standard angles, 90 and 30, and can solve it. But if it goes anything beyond that, it might be difficult. But when the angle goes bigger, allied angle and multiple angle come very, very handy. So if you see 120, it can be easily written as 2 into 90 minus 60, multiple of 90, and then you can do the math, and 60 will remain, and 60 is kind of a reference or standard angle, and you can easily play on that one and can solve that. Similarly, if you want to express this 120 as a multiple angle, then you can just say it as 2 into 60. So 60 is your A or given angle, and 120 is a multiple of 60, and you can solve it very easily. So that's kind of difference. When I break it down, see where it fits in. If it easily fits into a combination of compound angles, take the shot, do it compound angles. If the angles are too large and if it does not fit in easily, then more than likely it's going to be allied angle or kind of multiple angle. So that's kind of how you should imagine, and that's the reason I put the tips and tricks here as a thumb rule. Check if the question suggests you to solve in a particular rule. If they're asking you to solve in a particular rule, you will have to do that. So solve this problem using compound angle formula, so you don't have a choice, which is a good thing because the hint is given. But in case you're not sure which formula you should apply, then use this logic. Is it a smaller angle or a bigger angle? Can I break that angle into two smaller angles, which are standard angles, and I can run the value? If not, then let me move to allied angle. So that's kind of thing. Most of the cases, if they don't give you, you don't have to think about multiple angle, because multiple angle is a special case of compound angle. Just see if you can apply the compound angle very easily. If you cannot, by default go with allied angle, because allied angle will give you the solution the way you want. So that's just kind of an extra information in case you get confused, like in which cases I should apply what. Hopefully that case will never come, but if in case it comes, that's kind of the cheat sheet or the mantra that I'm giving you to kind of remember and process during the examination. So with that, I will wrap up this session on the concepts of multiple angles. And in the next session, which will be a fresh video, we'll just talk about a couple of problems that came in the last 4 years, and we'll apply multiple angles and just see how easy it is to score the marks. Thank you.